The United Nations is warning today of an approaching global water crisis.
The extreme example of a water crisis.
But locals say climate change is already robbing them of groundwater, and the companies are just making matters worse.
Over 1 billion people currently lack access to clean sources of it.
The report notes that water scarcity has the greatest impact on poorer people and children.
Hi, I'm Marcus Ongkai Liang, the representative of SMK Subang Jaya in the I3C International Competition. Did you know that 2.2 billion people worldwide lack access to the very basic necessity of human health and well-being, that is, clean drinking water? Two-thirds of our planet Earth is covered in water. Yet only less than 1% is actually usable by us humans. A study by the United Nations Environmental Programme has concluded that after surveying 75,000 bodies of water across 89 countries, that more than 40% of all freshwater sources have been severely polluted by human activity. H2Oable is a technology that aims to revolutionize the world of water treatment. There currently exists water treatment technologies such as reverse osmosis. However, H2Oable is special as we aim to solve both the problem of water scarcity and water pollution. H2Oable aims to use an integrated electrochemical method in order to treat wastewater to convert it into clear drinking water. Okay, so how does H2Oable work? Well, H2Oable is an integrated system that synergizes the electrophanton process and the electrocoagulation process. Big words, right? Don't worry, let's break it down. So, what is electrocoagulation? Electrocoagulation is a process in which sacrificial metal electrodes, such as iron electrodes, aluminium electrodes, or zinc electrodes, are used in an electrolytic cell in order to form metal ions. These metal ions released then bond with the hydroxide molecules or hydroxide ions found in the water to form metal hydroxides. These metal hydroxides are amazing adsorptive agents due to their properties which allow other molecules to bind to their surfaces. These adsorptive properties allow for metal hydroxides to facilitate the removal of total petroleum hydrocarbons, emulsified oils, and toxic heavy metals. The precipitate formed once the electrocoagulation process is finished will then be filtered out manually, and clear, palatable, and odorless water will be produced. So now we'll move on to the heterogeneous electrophanton process. So, the entire foundation for this process relies on one single equation, one single reaction, and that is the phanton reaction. The phanton reaction is when an iron 2 ion reacts with hydrogen peroxide to produce an iron 3 ion, a hydroxyl radical, and a hydroxide ion. But what we really want out of this equation is the hydroxyl radical. Why? Because the hydroxyl radical is a reactive species. It's a reactive species that has oxidizing properties, and these oxidizing properties can lead to the oxidization of pollutants such as microorganisms, microplastics, and organic pollutants such as pesticides, pharmaceuticals, phenols, and endocrine disrupting chemicals. So that was the phanton reaction. Now, what is the electrophanton process? Well, the electrophanton process is a hybrid technique that combines both the phanton reaction and electrochemical technology. So, why would we combine the two? Well, combining the two allows for the in situ generation of hydrogen peroxide. If hydrogen peroxide is generated in situ, we do not have to add it externally. And if we don't add it externally, this can make our system much more cost efficient and much more effective as well. So, the generation of the electrophanton process relies upon the two electron oxygen reduction reaction. This reaction is the catalyst for the generation of hydrogen peroxide in situ. So, for the 2-electron oxygen reduction reaction to take place, oxygen will be aerated into the system in order to facilitate the in situ generation of hydrogen peroxide. This oxygen will be aerated through an oxygen pump that will supply oxygen externally to the system. Alright, so lastly we'll move on to the heterogeneous electrophanton process. So to start, we have two types of electrophanton process. There's the homogeneous electrophanton process and the heterogeneous electrophanton process. So the difference between the two is that the homogeneous electrophanton process, which is the conventional method of the electrophanton process, takes place only in acidic conditions, whereas the heterogeneous electrophanton process can take place in a wider range of pH value, and this allows for its versatility and its adaptability to different situations, and it is this very factor that allows us to synergize the heterogeneous electrophanton process together with electrocoagulation, allowing for a much more cost-efficient and effective system. So, why should we combine the two processes? Well, both the electrocoagulation process and the electrophanton process have high energy demands, especially if scaled up. So, what if we could combine the two into one system in order to make it much more energy efficient? Well, this is exactly what H2O achieves. H2O integrates both systems into one single unit in order to allow for cost efficiency, effectiveness, and energy efficiency. Current models for the electrophanton reaction currently use cathodes made of precious metals such as platinum and gold. However, we have discovered that carbon can also be a suitable candidate for the cathodes in the electrophanton process, because carbon has suitable properties such as high porosity, high stability, and electrical conductivity. These properties of carbon make carbon a suitable candidate for the electrophanton process and for H2O unit. Our current model of the H2O unit uses activated carbon electrodes plated in iron. However, if we were to scale up the H2O model, methods such as heteroatomic doping or ion functionalizing could be used to increase the yield of hydrogen peroxide in the system. Overall, this system, the H2O model, is one that has great potential for growth, scalability, as well as versatility. H2O is the future, and I'd like to end with a quote. Thousands have lived their lives without love, but none have lived their life without water.